Hey guys, hi, welcome to another video, and in this video we will be discussing about the multipole expansion. So the first thing that we have to know is the monopole moment. That is the Q mono, it is equals to summation over I is equals to 1 to n Qi, and dipole moment is equals to summation over I is equals to 1 to n Qi Ri. So these are the formula for discrete charges. We have to keep in mind these are the formulas for discrete charges, and in this video we will be doing the sums so related to the discrete charges. Okay, so one important thing we have to know is that if Q mono it is equals to 0, and if the dipole moment is existing, then the dipole moment it is independent of the origin, means we can shift the origin. Okay, the shifting of origin will not create any change in the dipole. Next is if Q mono is not equals to 0 and if the dipole moment is existing, then the dipole moment it will depend on the origin, means if Q mono is not equals to 0, then we cannot shift the origin. Okay, because in this case the dipole moment is depending on the origin. These are the two important points that we have to keep in mind. Next is we will see the proportionality, okay, or the dependency of the potential with respect to R. So in case of monopole, the potential is inversely proportional to R and the electric field is inversely proportional to the square of R square. Okay, in case of dipole it is 1 by R square. Okay, and electric field is 1 by R cube. In case of quadrupole it is 1 by R cube potential, and electric field is 1 by R to the power 4. In case of octapole it is 1 by R to the power 4 and electric field is 1 by R to the power 5. This is very simple chart. You can just draw it in 2 minutes in examination if you directly don't remember what is the proportionality, or you can find it out also. But this is very easy. You can start with 1 by R to the power 1. Okay, for 1 again that is 2, 3, 4. This is just a logic that I am giving you so that you can remember. Otherwise if you can do it then it's very good. Now we will come to the sum. Okay, so I have solved here one sum. In other video I will give some more sums. For the timing I am giving one sum. So, okay, so concentrate on what I will be talking and what are the things that I will be pointing out. And if you want, then you can note down this sum, but before noting down I will request you first see what I am doing and what I'm speaking. Okay, then just write the question and try to solve it on your own. So here we are given that we have 4 point charges. Okay, minus q by 2, q and minus q by 2, means 2 q charges and 2 minus q by 2 charges, and these are placed at the vertices of a square whose side is a. So what you can see, these are the 4 charges and these are placed at the vertices of a square whose side is a. Again what is said, we have one another charge minus q, and this charge minus q it is placed at the center of the square. This is this charge. Okay, so let VR, here VR is taken to be the electrostatic potential at the point P at a distance R which is very greater than A from the center of the square. You can take any point. Okay, so you have to find V twice R by VR, what it will be. So we have to keep in mind we can find the dipole of a system. Okay, so for this what we will see, first of all we will find Q mono. This is the first thing we have to find. We have to check that Q mono is existing, means it is absent or present. So Q mono is equals to what? Summation over Qi. So here we are having 4 charges, this Q plus minus q by 2 plus q plus minus q by 2. Okay, so and one more charge is there, this is minus q. We have to remember this also. Now adding all these charges we will get that Q mono is equals to 0. That means it is absent. Now when this Q mono is absent, then we will check what? We will check the dipole moment. Okay, monopole moment is 0, so we will go for the dipole moment. So for dipole moment the formula is Qi. Okay, summation over I Qi. Okay, that is the charge into with the distance. Now what we will do, we can see what this side is A. Okay, So from this center, this point to this point, this is how much? A by 2. So it will be A by 2. And the sign we have taken, this is representing the xy axis. Okay, we have drawn a xy axis here. This is xy axis. And you can keep in mind this minus q by 2, it is at a distance how much? It is at a distance, y axis is still here, x axis is still here. That means we will use the sign according to the quadrants. It is the basic thing which you have got in your intermediate time or in your school time. So what we know that in the first quadrant both x and y coordinate are positive. In the second quadrant x coordinate is negative but y coordinate is positive. In the third quadrant both the x and y coordinate are positive. And in the fourth quadrant x coordinate is positive but the y coordinate is negative. So this is what you have to keep in mind, and you have to put it as a by 2 x cap, a by 2 y cap. This will be minus a by 2 x cap and this is a by 2 y cap. This is the thing that you have to keep in mind. And when we will you write qi ri for each charges, we have to proceed in this way. So firstly for this charge q, it will be how much? A by 2 x cap plus a by 2 y cap. This is ri. Okay, this is the distance. Ri is the distance. Next is minus q by 2, and this time it will be what? Minus a by 2 x cap plus a by 2 y cap. Similarly for this q charge also you can write, it will be how much? Plus q charge minus a by 2 x cap minus y by 2 y cap. Similarly for this one will be a by 2 x cap minus a by 2 y cap. Now in the next line what I have done, I have taken this positive q common. On taking positive q common, you will see all other terms will get cancelled. And if I take minus q by 2 common, here also all other terms will get cancelled. That means the dipole moment is also equals to 0 here. So when the monopole is also equals to 0, the dipole is also equals to 0, then we will have the quadrupole moment. So the quadrupole moment is present. So the potential is inversely proportional to 1 by r cube. And now we will find V2R by VR's ratio. So it will be how much? 1 by 2R whole cube into with r cube by 1. Okay, just I have reversed it because it is 1 by r cube. So r cube will go to the numerator and this r cube and this r cube will get cancelled. And 1 by 2 cube is equals to what? 1 by 8. So this is equals to how much? 1 by 8. That is the correct option is option D. So this is how we can solve the problems related to the dipole, and it's very easy. Nothing is complicated. You have to just remember the formulas, and we have to keep in mind this is only for discrete charges. For continuous charges I will do it in some other video. So that's all in this video. Thank you so much. Have a good day, and please do not forget to subscribe to my YouTube channel. Also hit the bell icon so that you get all the notifications. If you have any questions, queries and suggestions, then please comment me in the comment section. Do like and share the video. Thank you so much. Have a good day.